Hello and welcome back. Alright, we're looking at our header file that we just got done writing out, and we're going to go ahead and implement the remaining functions to get our expression tree working. So let's just go ahead and jump over into our code file, and the first thing we're going to do is we're going to go ahead and fill out this constructor. Now, if we jump back over to our header file, you remember that we have this operators map, the static operators map. And what we want to do is we want to populate this map with all of our operator information. Now, since it's static, that means it's going to be shared across all classes. And so that means that there's only going to be one of them through all regardless of how many instances of expression tree you actually create. So the first thing we have to do is we actually need to copy this over, and since it's a static operator, or sorry, a static field, we actually need to give it a definition. So right now we've only declared that variable inside the class, but we actually haven't given it a solid instance that the class can point to. So in order to do that, we just copy that over, and let's go ahead and scope in the operator map and the operators. And what this does is this tells the class, hey, this is the specific instance of operators I want to use when you reference that field. Okay. So now in our constructor, what we want to do is we want to populate that operators. But since it's static and shared across multiple instances, we only want to do that if our operators map is empty. So if operators.empty, let's go ahead and fill out our operator list. Now, I do want to note that this is not thread safe. I know we haven't really talked about threads, but in case you're aware of threads and multi-threaded programming, this is actually not a thread safe constructor. And that's okay for the purposes of our video. Essentially, what I'm talking about is if you have multiple threads and they both create an expression tree at basically the same time, you can get in this funky state where the operators isn't empty, but that map's not fully initialized. But that's way out of the scope of this this series, at least for right now. But I just want to give you that caveat. Okay, so now we need to add all of our operators to the operators map. So to do that, we just type out operators, pass in the operator string, set it equal to the expression tree operator info. Oops. Case that correctly, and then we're going to give it a precedence, and we're going to say the plus is precedence 0. So it's arbitrary. We're going from the lowest precedence up, so it'll start at 0. So now the next thing is we want to say, hey, we want to use that add function. So I'm actually calling a constructor here that I don't believe we defined in our header file. So let's go ahead and first let's look and see what we're doing. What we're doing is we're passing in the precedence that we want for the operator and a function pointer to the function that we want called that relates to that operator. So if we see a plus, obviously we want to call the add function. So let's jump over to our header file. And if you want to know what I'm doing to jump back and forth in Xcode, I'm holding down the Option Command key and pressing the Up key, and that jumps to the corresponding file. So if it's a C++ file, it goes to the header file. If it's a header file, it goes over to the code file. Okay, so in our struct, we need that constructor. So let's go ahead and type out operator info. Remember, we're doing the precedence, so we'll do a variable or a parameter into P, and then we need that operator func. So it's just operator func, and we'll call it F. And then we'll just do the field initialization. So precedence is P, and func is F, and an empty body. Okay. So now if we jump back over, let's go ahead and copy and paste this line. Oops. And add the rest of our operators. Get a few in there. So minus is going to have the same precedence as plus. Standard mathematical rules. And we'll do subtract. And we'll do multiply. I'll just go ahead and fill these out. Divide, left parenthesis, right parenthesis. And we want to add a special token inside of our operators. And I'm going to use the pound symbol, the hash, shift 3. And what this symbol is going to represent is going to represent the bottom of our operator stack. And our implementation of our operator stack We'll get into it more when we actually do it. But the idea is that we don't want a special case whether or not the operator stack is empty. Because remember, we have to do this check to see if the current operator has a lower precedence than the operator that's on the top of the stack. And if we didn't add this special operator symbol, then we'd have to do a special check if the stack was empty. And so in order to avoid doing that, we're going to go ahead and add this fake operator to our code. Okay, so let's go ahead and update our precedence value. So multiplication has a higher precedence than addition and subtraction, so we'll just use 1. Division has the same precedence as multiplication, so that's 1. Now, a left paren has a higher precedence, but we're going to handle this, we're going to special case the parentheses. So we're going to give them a -1 to give them the lowest value. And our special symbol is also going to get -1. All right, so now for our functions, we need to change the multiplication to multiply, the division to divide. And then for our left parenthesis, right parenthesis, and a special symbol, we're going to give it null. And that's because there is no corresponding function to call for those operators. Okay. So there's our expression. There's our operator initialization, I should say. The next thing we want to do is in our expression tree is we actually need to convert that string that we're getting passed in into an actual expression. And so we can either create a helper function here to do it for us, or we can just do it in place. But since there's a lot of code, I'm actually going to do a helper function. So I'm going to call it fromString. And we actually already defined that in our code as well. So here's that fromString. And so that's what we're going to define next. So let's go ahead and copy this. Jump on over. And we'll put it down here. Okay, let's scope it in. All right. Okay. So now what we want to do is our expressions could look something like this. They could do 1 plus 2 times 3. Well, we're going to use some built-in C++ string parsing routines. And in order to make this easier, what we actually want to do is we want to transform the string in this form and turn it into something that looks like this. So what we're doing is basically making sure that there's a space between each token in our string. And we're doing this so that we don't have to come up with a bunch of rules when we parse this string. And we can just read right through it and just break in all the white space characters. Okay, so in order to create this string, what we want to do is we notice first that this is a constant string reference. So that means we can't update this string. And I'm actually going to rename this parameter to expression string. Okay, and so now I'm going to create a copy of this string. We'll call it stir, and we'll give it the expression string. And that just creates a copy of what we have passed in into a string that we're going to manipulate. Okay, and so now what we want to do is we want to iterate over the length of that string and do some work on it. So we just do for size of t, I equals 0, I is less than stir.length, plus I. Okay, so this size t is really just a type def for an unsigned integer, but it gives us one of the right size for whatever string is using as its backing length string, or backing length value. And technically that's what length is going to return, so to be all correct, we'll use that size t type. Okay, so now we're going to take each string that we find out of here, or each character we find, and convert that into a string. So what we need to do is create a string op, and we're going to do op push back, and it takes a char, and so, oops, that is going to be stir I, and there we go. And so now the question is the character that we found an operator? Okay, so we do if operators.find op does not equal operators.end, then we know we want to actually go ahead and determine if there's white space surrounding this operator. And so now we only need to do this for operators because every number is going to be separated by either an operator or the end or start of a string. So basically, we always know that operator is going to be in between our values. Okay, so if we find this, we're going to call this special helper function called add whitespace. And what we're going to pass in is we're going to pass in the index that we want to check. That's I plus 1. And then we want to pass in the index of where we want to insert our space if we actually do need a space. And so for the case of looking at the I plus 1 value, so let's say we're looking at, we've gone through this string, and let's say we're on the right paren right here. Well, so what we want to do is we want to check, hey, is there a space here? And is there a space here? Now, when we go to insert a space, we actually want to insert that at the I plus 1 value. But when we insert it on the I minus 1 check, we don't actually want to insert it at I minus 1 because the I minus 1 is where this cursor is. And so if we subtract another one off of that, we'll actually add it up over here. So we actually want to change it at this location, which is I. Okay. And then we also need to pass in the string that we want to manipulate. And we'll call add whitespace again to I minus 1, I, and stir. And again, just to be clear, this is telling the function that, hey, if my cursor is at this right parenthesis, I need to check this value. Is this white space? No, it is not. Okay, so then where my right parenthesis is, I need to add a space. Okay, so let's go ahead and define what this function does up here. We'll call it add whitespace. It takes in an int. We'll call it index. We'll have another int I and a string reference stir. Okay, I'm actually going to change this. Okay, so this is pretty simple. We need to do a couple of checks. Let's actually change this I to insert at, just so it's more clear. Okay, so now what we need to do is we need to validate that our index and our insertion place are all a valid location within the string. Alright, so if our index is greater than 0 and our insert at is greater than 0, greater than or equal to 0, sorry, and our index is less than our stir.length, and our insert at is less than our stir.length, then if the location that we actually want to insert at, or we want to validate, is a whitespace character, then we're going to go ahead and insert the function. So and stir at the character position of index, or the character at position index IDX does not equal whitespace, then we're going to call the stir.insert at insert at. Let's go ahead and put this on a new line. It's going to be kind of long. Insert at 1 and a space. And so what this stir insert function does is it inserts a character value, which is this right here, at the given location, this insert at index, and this 1 is the number of characters to add. So if I were to give the value actually 5, it would add 5 whitespace characters at that location. And that's not what we want. We just want to add a single whitespace. So this is what that code looks like. So let's make sure our conditions are correct. Index greater than or equal to 0, insert at greater than or equal to 0, index less than strength, index perfect. Okay, so there's our add whitespace function. All right, so this has converted our string into the proper form. Now what we want to do is we actually want to go ahead and do the algorithm that we whiteboarded a couple videos ago. So we need a couple variables. We need a standard stack that's going to have strings in it, and this is the operator stack. And let's go ahead and jump up and make sure we have a stack. Okay. And then remember, we need to add that special value. So we're going to have operator stack.push that oops, it's a string. Okay, now we've added that special operator. Now we need the operand stack. And remember, that's going to be a stack of node pointers. Operand stack. Okay, and we're not going to push anything on there. Let's go ahead and just group those together. Okay, so now here's the heart of our algorithm. We need to grab each token out of our string, each item that we care about, and determine if it's an operator, or if it's not an operator, create our node and shove it onto our operand stack. In order to do that, we're actually going to make use of a built-in class called the iString stream. And what that is, it's an input string stream, and it allows you to treat a string as a stream of bits. And that allows us to use the shift left and shift right operators to actually parse data out into a value. And that actually allows us to take our numerical values and turn it into a double, or you could use an int or any kind of type. It has all the built-in type coercions for us. So we need to go ahead and create or include that up here. So we're going to be including sstream, I believe is what it is. Yeah, sstream, and that's good. Okay, so now our algorithm basically we need to create that iString stream. We'll call it SS, pass in stir, which is our preprocessed string. Okay, and now what we want to do is we want to iterate over it while SS does not equal the end of its stream. And that is determined by the end of file function right here, EOF. So what this is going to do, this is going to break every, so here's our preprocessed string. It's going to return, it's going to basically shove a value. Here, let me create a string first. We'll call it string S. So this shift operator right here is going to break on white space. So the first time it goes through here, it's going to give you that left paren. The second time through, it's going to give you this 1. Second time a plus, 2, paren, star, 3. And so it's going to skip all the white space for us. And so if we had a value like 2.13 or 123, it's going to give us that whole 2.123 value. And that's exactly what we want. Okay. All right, so now we have read in our first string value. So now we need to check to see if it's an operator. We know how to do that. If operators.find s does not equal operators.end. Now, this is where we're going to do our special casing of our left parentheses. Remember, we made the parentheses be have a low precedence, but in reality, they have the highest precedence. So, if s equals our left paren, then we're going to go ahead and just add that onto the stack. We're going to add our operator onto the stack. If s happens to equal the right parenthesis, well, remember from our whiteboarding video, we need to pop all of the operators on the stack until we get to the left paren. So while operators.top does not equal our left paren, we're going to need this special code to pop operators. And if you remember from our whiteboarding video, the pop operators function actually takes the operator off the stack, pops 2 operands off the stack, creates a new binary node, shoves the operands into the right and left, and returns back that node. And we'll go ahead and call this function pop operator. So I'll delete this comment. Let's go ahead and define it right now. So it's going to be pop operator. And what it needs is it needs a reference to the operator stack and the operand stack. Okay, so let's just go ahead and define it right here. Void pop operator. It's going to take a standard stack of strings, and that's the operator stack. Oops. It's going to take a reference of that in a standard stack of node pointers, a reference to that, and that's the operand stack. Okay, so remember, we need to create a binary node, so expression tree, node. We need to scope this in because this pop operator does not actually live within the expression tree class. It's a function that is scoped to this file. Basically, it's a private function for our little function that we're writing here. Okay, so we need to create a new node. N equals new expression tree node, and it takes in the operator stack.top. And so that gets the string value of that operator that we're dealing with. And then we go ahead and pop that item off the top of the stack. Okay. Now we need to set the right and the left to the top values of the operand stack. So we do n right equals operand stack.top, and then we pop that value, and then we do the same thing for the left. And then after we do all that, we need to shove this new node back onto the top of the operand stack. So operand stack.push n. Alright, so that's the whole functionality of that pop operator, and we do that every time we pop an operator off of the stack. So that's why I created a helper function for it and didn't just write this in line. Okay, so we're popping all of our operands off the stack until we hit a left paren. And we also need to get rid of that left paren after we've done everything. So we have operator stack dot pop, and that gets rid of our left parenthesis. Okay, so now we've handled the left paren and the right parenthesis. Now what we need to do is we need to handle the precedence of our operators. So else if our operators dot operator stack dot top. All right, if the precedence, and so remember that the operators map holds a map of strings, which are the keys, and operator infos, that are the values. And our operator info has a precedence field. All right, so if the item on top of the stack has a greater than or equal precedence, then the operators, then the current operator's precedence that we're looking at in our string, if that's the case, if I can spell this right, if that's the case, we actually want to pop the current operator and push the operator that we're working with onto the stack. So we call pop operator, operator stack, operand stack, and then we push the operator that we just parsed onto the stack. Okay, and now finally, otherwise, we just add the operator to the stack. So that means the operator had a lower precedence, and so, had a higher precedence, and so it actually needs to be evaluated first. And so by pushing it onto the top of the stack, that guarantees that it will be. All right, so now this whole block of code has handled all of our operator conditions. We have the left parenthesis, we have the right parenthesis handled, and then we have the correct precedence handled as well. Okie dokie. So we do else. So now what we've actually read in is a operand value. And so whenever we see an operand, we create a new node, and we give it the string that we just parsed, and then we add the operand stack dot push new node. Okay, so that's our entire string parsing function. So at this point, we need to check to make sure that our operator stack is empty, because it's possible that we've done nothing but add operators to the stack. So let's say we had the expression 1 plus 2 minus 3. Since the plus and the minus never caused this pop operator to happen, well, actually, I guess it would have with this one. But you could have had 1, let's see here, times 2 minus 3. Would that work? So if you had 1 minus 2 times 3, you would end up with the multiplication operator on top of the stack, and then you'd have to deal with the minus. So in that case, we need to actually go ahead and pop all the operators and onto the stack. And so we iterate. So while the operator stack dot top does not equal our special character, we go ahead and pop the operator. Operator stack, operand stack. And at the end of this, what we end up with is our last value, and our top value in our operand stack is the actual root node of our expression tree. So we set root equal to operand stack dot top. Okay, so just to clarify, this is our special character that we need to check for. So in here, if we didn't have that special character, we'd have to check to see if the operator stack was empty. But this is the real place that makes this code easier. We don't have to check to see if the operator top value right here that gets back, if we didn't have this special, operator in here that designates a low operator in the stack, we would have to also add the operator stack.empty here. Otherwise, this top would throw an exception. Okay. So if we build this, I have 23 errors. String was not declared in this scope. Let's see what line I am on. Pop operator. Oh, I have not scoped in string properly in on my pop operator function. I have also not scoped in node properly in the stack for the parameters. So let's see here. Did I forget any others? I think the rest of them are good. Let's build and find out. 18 errors. Expression node. That's expression tree. Sorry. Expression tree node. We build. Now we're down to 4 errors. Love C++. There's no lefty. Come on. I'm sure all of you have spotted all my errors. The joys of coding in a video. Okay, so I'm doing something funky here. While operator's top does not equal left, let's see, expected. Oops, I always double click. That doesn't help you guys because it opens a new file. Let's just go look for the error in this line. It's missing. Okay, let's see here. Operators. Let's just see what line it is. There's no member named top. Operators. Where's that while loop at? Oh, sorry. This is supposed to be operators. In my while loop, we're iterating over our operators. No, that was right. Operator stack. Did I type something wrong? That is right. Oh, we got a problem up here while my operator stack. Sorry. So inside my right parenthesis, I'm iterating over in the wrong type. That should be the operator stack. All right. We rebuild. We're down to 2 errors. We're getting there. I just simply forgot a semicolon somewhere. What line is this on? It is on right here. Oh, actually, we're getting a funky. Xcode's been doing this to me lately. It's showing these phantom errors, like this guy right here. We just fixed that one, but unless I close the file, it doesn't get rid of it. That's actually quite annoying. So down here on my operator push, I actually put a semicolon on accident. Wow. Down to 1 error. All right, no matching call to operator info. Oh, so we need to actually add a default constructor to our operator info class. Operator info. Okay, so now we rebuild. Oh, we have 1 more error. Did I type something incorrectly again? Okay, so we got a link error, expression tree, operator info. Oh, that actually has to be an empty body. So the problem there was that I defined the function that I was missing, but it actually, I declared it, but it didn't actually define it and give it the actual implementation, and we just want that to be an empty body. Okay, that was the longest coding error fixing in a video in a long time. Sorry about that. Most of it was a lot of bad typos, and then I forgot to add our default constructor. So we needed that because we're actually passing around um, instances of this thing, and so we need those things to be able to recreate themselves. Okay, so we build, everything succeeds, we go, we run. Oh, nothing's happened because we have not actually implemented our evaluate function yet. And so what you could do is you could print out your tree at this point to test it and make sure that it's working correctly. But I'm just going to go ahead and implement our evaluate, and we'll use that evaluate as our sanity check to make sure that our expression tree is being implemented correctly. Okay, so let's go ahead and jump up to evaluate. And what I'm going to do is I'm passing in this node pointer. And this is the node that I want to start evaluating from. If you remember in my header file, I can jump back over there, we gave it a default value. And that default value is null. So, in my implementation, if the node is null, I'm going to assume that you wanted to start evaluating from the root node. So then, if it is null, we will set node equal to root. All right, and now here's where we're going to do our magic of our evaluation function. So we know that we want to evaluate the node. So if a node is an operator, it's going to have a left side, it's going to have a right side, and that node value is the actual operator. So what we need to do is we need to get the function that corresponds to that operator. We're going to pull that out of our map, and then we're going to pass the evaluation of the left side of our tree and the evaluation of our right side of the tree into the parameters of those functions. Because remember, the functions take two parameters, a double x and a double y. And so we're going to use recursion to allow us to do this. So the first thing we need to do is we need to look to see if the node value that we're at is actually an operator. So we do node arrow value. All right, and so if this iterator value doesn't get back with end, that means we've actually found an operator. So if our does not equal operators.end, we know that we have found an operator. And so this is where we need to do that evaluation of the left side and the right side and pass that into the function that we get. So we have a function pointer already because we have that iterator. And remember, the iterator gives you back a first and second value. The first value is the key of the map. The second value is the data for the map. And so our data is an operator info. So what we do is we want to call return, and we're going to put this in parentheses. We're going to do it arrow second. And so that gives us the operator info item from the map of for the operator that we've just found. So if the operator happened to be plus, what it's going to return to us is this operator info right here, where we can get the precedence if we wanted to, or we can get the pointer to this function. We want the pointer to the function. So we're going to do dot func. And so that gives us the pointer to that function. And so what I've done is I put that in parentheses, and that tells the compiler that, hey, this is some code that I actually want to call. This is how you call a function pointer, basically. So now, remember, we want to pass in the parameters. So if you actually just look at this, this is like calling the function name if I had add here, for example. So what we need to do is we need to pass in the parameters. And so we know that we actually want to evaluate. We want to evaluate the right side and the left side, or the left side and the right side, actually. And then we'll call evaluate here, node right. And that's it if we had an operator. So we know that we also have another case. We have the case of the node actually representing a numerical value. So we want to convert that numerical value if that's the case. So if we didn't find an operator, we're going to create another iString stream. And remember that we can use that to parse our value. So we're going to call it s again. node value. So now we can create a double value, and we'll use that shift operator to coerce our string value into a double. Basically, it's going to do the parse or the conversion for us. Happened all nicely, and then we will return that value instead of returning 0. So let's take a look again at what our evaluation is doing. We're setting this new node to the root if we didn't pass in a node to start the evaluation from. Then we're going to ask, hey, does that node value, is that node representing an operator? If it is, then we know we want to evaluate the left side of the tree, and then we want to evaluate the right side of the tree. And that's what these two pieces of code are doing. And so this is our recursive call. And so this is what's going to allow us to go all the way down the tree and evaluate the tree for us. And then down here is basically our base case for our recursion statement, right? It says, hey, you didn't find anything, so we're not going to actually do a recursion here because this is the ending point. The ending point is when the node that we're looking at is not an operator, it's actually an operand. And that operand is a single numerical value and not an actual subtree. So if we go ahead and build this, hopefully I don't get 23 errors again. All right, we build, and if we go ahead and run this, we can say, hey, we got a value back. We got 6. So now let's go ahead and check to see if we're right. Well, we did 1 plus 2, which is 3. So we know that based on standard math rules. So then we have 3 times 4 divided by 2. So it doesn't matter which order we do these in. So we could divide 4 by 2 first if we wanted to. So then we'd have 3 times 2, which does in fact equal 6. Or we could have 3 times 4, which is 12, and then divide that by 2, which is also 6. So we can see that it works. Let's go ahead and jump over to our main CPP file, and let's go ahead and change this expression around a little bit. Let's say we had 1.25 times 4. Okay, that's a pretty simple expression. Run it. We can say, hey, 1.25 times 4, that does equal 5. Ah, perfect. So it looks like our code is actually working. And so that is our expression tree. Now, I'm going to show you one more thing. This actually isn't supported in Xcode, but this is kind of what you can look forward to when the new standard of C++ comes out. You know how we defined all of these add functions? These guys right here. Well, in the new version of C++, there's actually going to be this thing called the Lambda function. So that would have allowed us to not actually have to define these here. We could have defined those in line. And the syntax is pretty funky. I won't show you that, but I just want to give you a heads up on what's coming and what could change in C++. So in this operator here, instead of passing this in, we could have actually done something like this. I actually forget the syntax for lambdas. But basically, you could write them in line. Let's say you had double x, double y, and it looks something like this. So if you're using Visual Studio 2010, you can actually play around with Lambda functions. I don't remember if this is the exact function, so just go ahead and Google C++ Lambda functions. Or you can look for C++ OX, which is what the new standard of C++ is going to be called. And then Lambda functions. Lambda looks like this. Lambda. So if you Google this term right here, you'll make sure that the syntax is right or not. But basically, you can define your functions in line, which is really great because we could have done that for our add white space as well. We could have just created a nice little variable inside our function and not have to pollute our file scope with that function name. So I just wanted to give you a heads up on that. I know that's probably, you guys are like, what the heck is he talking about? But anyways, so there's our expression tree. There's a little tidbit on what's coming in C++ OX standard. And that's going to actually wrap up this segment of our software engineering class. Upcoming, I have some good news. We're actually going to write a real program. And then we'll go on and walk through the design of that and get some real experience putting in all these concepts that we gather, all the concepts that we've learned together. And I think that'll actually be pretty fun and a nice change of pace of this kind of theoretical application of, hey, how do we use this new tree concept that we just learned? Well, we're going to use an expression tree, because clearly you're going to want to write an expression parser. Arbitrary problems. We'll try to turn those arbitrary problems into actually real problems that hopefully more people will be interested in learning and kind of pick up the pace of this course. So with that, thanks, and until next time.